So hello everyone, I am Harshana Stati and I am currently a research scholar at Department of Astronomy, Astrophysics and Space Engineering, and also I am your host here for this radio astronomy course. So welcome again. So in this tutorial lecture, what we will do, we will learn something about Python, which is a programming language. And what we will do in this lecture is we will introduce Python language as a computational and visualization tool, not as a programming language, but like a computational and visualization tool. Okay, so to begin with, what we can learn here is what are the how to use Python as basic calculator. Okay, then we will also learn how to use Python as a visualization tool. Which means we will use this for plotting. Plotting means physically representing any data. Okay, and also we will learn what are called data types. So data types just refer to a kind of number system. Okay, and also symbols. Symbols means like we assign character or string or something like that. Okay, so if you want to string hello, like what I am writing here, it will be stored somewhere in some variable and which we can use to display on the screen. Okay, so this is what we will do in this particular session. Okay, so let's not waste our time and just let's begin with the crash course. Also I will be showing you the whatever we write in a Python. Python is we call code. Okay, this is nothing but we represent in terms of kind of equations. Okay, or commands. Also, for this we will be using the free Jupyter notebook by Google. So Google Colab, you can use Google Colab to understand how to use Python, and there we can write it line by line and see what are our results. Okay, so let's begin. So what we will learn again here, what I will say, we will learn about different data types. So data types are basically what we said: numbers, strings, okay, printing, then list. There is something called list. We just like a grocery list we create, there is something called list in Python. Okay, so we will discuss all these things. What are these? Okay, so numbers, as we have learned in our elementary schools, also means like in class 11, 12 up to our higher education, that there are different kind of numbers. Okay, complex numbers, then there is decimal number, then you have real number, and also you have integers. Okay, so these are different kind of numbers you have. Okay, the same thing you have in Python. Okay, there are certain limitations if you approach it in from a computer science manner, but we will be using this as just a simple computational tool and visualization tool. Okay, so how to utilize Python effectively, we will learn here. Okay, so let's see first here the numbers. What are the numbers? So one is a kind of number, right? So here So how do we add a number here? Okay, so to simply using as a calculator, we can do 1 plus 1. Okay, and we have to just click here run. Okay, it's already means I already ran it, but so for uh, demonstration purpose, what I can do is run this, and by running this, it will connect to the server here. You can see this one. So when you open Google Colab, it allots you a certain amount of memory as well as a certain amount of RAM. Okay, now by this, what you can do, you can get into you will be allotted a kind of computational device, a free computational device, where you can run the Python program. Okay, so 1 plus 1 2. Say if I change it to 5, say 5.8, okay, decimal, so it will show the decimal value 6.8. See, similarly we can multiply, divide, and we can do power operation also. Power operation, we generally the general notation can be everyone means those who do programming in other languages, they can they say that it will be like this, but in Python, double asterisk means you are doing power operation. Okay, say 2 to the power 4 is what, 16. If you run this, you will get 16. Okay, so just to verify it, you can do it with 6, so you will get 64. And also you can do decimal power also. So 2 to the power 5 is 1.414. okay, so and then there is a modulo operand. Modulo means to verify whether the number is perfect division or not, or whether it keeps a remainder. Say here, if we divide 4 by 2, then you will get 0 remainder. If we divide by 3, then we will get remainder 1. So this operation, the percentage operation, is called modulus operation, by which shows that a remainder is, what is the remainder. Okay, say if I do 1, it will say 0. Okay, if I say 5, 4, because 5 cannot divide 4. 5 is larger than 4, so entire 4 is the remainder part. Okay, so now coming to the means commutative and other properties, like it will follow the Badmas rule. Okay, brackets means Badmas rule, brackets, addition, multiplication, and all those things. Okay, that whatever rule we learnt in our higher education, that rule it will follow. Okay, now coming to an interesting part, variable. So in linear algebra as well as the arithmetics, what we do is we assign variables to different quantities. So here also we can do that. Say we can define a variable as name of the variable and then equal to what its value is. Like here I can say x equals to say 6 and y equals to 7. Okay, say 7 point some value. Okay, now I will run it. X and y has been assigned with the certain value, the given values. So with this, if I say z equals to this, and just to see the value what is stored in z, we can just run z and we can run this code. We will get 13.9587. Okay, so this is how you do general simple arithmetics. Now coming to the other data type, which is called strings. You can denote string, have strings in single quotes as well as double quotes. Double quotes provide you the leverage where you can use single quotes in the text. Okay. Now, similarly, with the strings also, you can define a variable, and through the variable you can using variable you can see what is in the variable. Okay. Now there is something called print command. Print command, what it does, it displays what is inside the variable onto the screen. But the question will come here. This line also shows same, correct? See x. If I run this, we will get hello, right? Say let's do this one. Okay, so hello. Okay, if we run this, we are getting hello, and if we run this also, we are getting hello. Okay, but the difference is here in this particular line, it is showing what's inside the variable, what is stored inside the variable, whereas print command is saying that to show whatever inside in the variable on the display. This is only for the compiler or interpreter to understand. There is something called compiler interpreter. Interpreter, what it does is it executes only single line of code. So if there is a variable, it will show the what is inside the variable. Okay. Now, whereas print, it will display onto the screen. If you run the code, this code like some kind of script, means humor me for a second. Means there is something called script where you can write entire thing and run it on a single go. You don't want to run step by step just like what we are doing right now. Then in that case, what will happen? The print command becomes necessary to display the variables on the screen. Okay, so that is where the print command is used. Okay, but don't take tension about this print command, but that's just for introduction, and we will just use this as a mathematical tool as well as visualization tool. I am repeating it again. Okay, so just this is to refresh that how to use Python, and if you are interested and you can dig more deep about it using a computer science way, computer engineers approach to understand what the language is and all those things. Okay, now similarly we can give multiple variables and we can print in different formats and all. Okay, now this is what this says is you have you can how you can print two variables in a single line. So you have to define one in curly braces and two here curly braces, and then you have to format what is 1 and 2 here. Okay, instead of 1 and 2 you can use a, b, whatever variables like that. Okay, and it will print like this. Okay, in fact if you don't do anything, don't give anything, just in dot format you give the name at the specified means order, in the specified order it will print the same. Okay, now coming to something called list. Okay, this is something important. Just like we make some kind of means to-do list, grocery list, something like that, there is something called list. Okay, so we saw what a variable is. Okay, now there is something if you want to store multiple things in a single variable, then we can use list. So list is defined as shown here within square braces. Say if you have a square bracket, then this is list. So here something is called list of list. So you can have a list inside that. Say this 1, 2 is again a list. So this is list of list. And similar to the value definition in defining a value of a variable, we can define a variable for list also. Okay, so for example, if you have my list here, okay, now this is ABC is our list. and that is in my list. Now if we want to append another item to the list, what command we should use? We should use dot append. So my list dot append d, what it will do, it will append the d letter into my list, and if we print this, we will get ABCD. Okay, now and then there is something called list indexing. Okay, something called list indexing. So indexing is what? Say if we have, for example, if we have the list A, B, C, D here, indexing means how we will print only A. I want only A from the list. Okay, so just like a matrix, it is defined as ij. Okay, any matrix can be defined as ij. So here this one, the first one is 0, then this is 1, 2, 3. Okay, it starts from 0. So if I say list of 0, it will print A, 1, B, and if I want to print from 1 onwards to the end, what I will do? I will do 1 colon, that's all. Okay, but remember, we have to do it in a square bracket. Okay, so it will print BCD. Okay, similarly, if I want to print from starting to 1, it will so I will put this. But one thing to notice here, if we say 1 colon, it will print till the end. Okay, and if we say colon 1, that means before 1, print whatever it is before 1. Okay, so if I say generalized way, so in generalized way, what I can say is list in list say 1, if I want to print anything from 0, it will 0 to n, so it will print till n minus 1, 0 to n minus 1 location. Okay, so this is how it is. Okay, now what you can have, now this few examples shows how you can have list inside list. Okay, so these are this particular notebook will be shared with you. Okay, now you can go through in detail. I will skip few concepts, and not skip, I will go a bit faster through that. You can just go through it and you can experiment and see what can you do, and you can get it, what you can do. Okay, so simply say list of 0, we can change means like the specifying the location also. So if I change it 0 change to new, you can see new here. Okay, similarly you can have a nested list. Nested list means one inside another, or list of lists, something like that. Okay, so 1, 2, 3, then inside this there is another list, 4, 5, then this. So how you will see this? So if we put 3, then 0, 1, 2 and 3, the 4 to 5 is, this is the entire list is in the third position. Okay, so it will show the entire list. So it is kind of, you can say, a 2-dimension or the 3-dimension thing. Say if I print 3, 2, so it's saying from the third element of the list, print the second element of the list, means list of list. So it will second, what is 0, again 0, 1 and 2, that is target. Okay, now from the, this is also a list because it's under square bracket, so you can write list of list of list. Okay, so similarly you can have multiple nested lists. It will help for different reasons, means when you go too deep into data analysis and all, so it might help sometimes. Okay, now going to something called as dictionary. There is another data type which is called dictionary, where you can assign a key to an item. Okay, just like you have a dictionary where you can search by letter, then you can go by alphabetical order and you can find out where the word is and what is its meaning. Okay, so similar to that, you have a key here. That key can hold an item. That item can be a single number or a list or something called there is another data type called tuple that can also be there, and also you can assign another dictionary to that. Okay, that is also there. So and with dictionary, what you can see, D, for example, if I run this, it will store this dictionary value into this. Okay, now if I want to see what is inside the key 1, what I will do, I will run this. It's saying inside key 1 is item. Now say for example you forgot what are the keys in the dictionary. So what you have to do, just type keys, enter. Okay, sorry. Okay, so keys bracket open close. So it will show what are the keys inside the dictionary. So key 1, key 2, there are only 2 keys. Okay, you can assign any different name to the keys also. Say I will say A, and then same thing, and then same thing. So now it became A, right? Now other than this, there is Boolean operation. Boolean operation is basically true or false operations. So true represented by the word true, TRUE, false and false. Okay, now how you can check that what is true and what is false? Else you can do logical operations on that. So for example, I will say 1 is greater than 2. This is a false, right? So false. So this is Boolean operation, where if you do any logical operations, that will also result in Boolean answers. So sometimes it is necessary to use Boolean operations where you have only limited means either something can be true or something can be false. That then and then only you should use Boolean operations. Okay. Now there is something called tuple. So tuple is a data type which is not changeable, which is unchangeable. Okay. So what happens in a tuple, when you assign it, it can't be changed. So tuple is mainly used to assign constants. Like say if you have something called say you have Rydberg's constant, so it won't change, right? Or Boltzmann constant. So you can say E minus 23. So this is, I write it is E minus 23. That means 10 to the power minus 23. It is also called Mentesa format. So if I have this, okay, then if I run this, so now if I by mistake in somewhere in my when I'm doing some kind of computation, I'm trying to change this to any other number, it will throw an error. Okay, so tuples are unchangeable data type. So it once assigned, it will remain same. So it is very useful to use tuple to define constant values. Okay. So then comes something called sets. Okay, sets, just like our mathematical set operations, we also have sets here where we can use where we can use the curly braces to denote sets. Okay, so this is how you can define set, and you can define it as a variable also. Now as I said, we can do logical operations also here. So greater than 1, less than 1, so true, false, whatever it is, equal to operation, greater than equal to or less than equal to operation. And okay, so you can also compare strings over here. Okay, you can also compare strings, like say hi equal to by. What is it? Is it equal? I don't think so it's equal, so false. Say, even if I say hi equals to capital HI, it will say false. Why? Because it is small h, it's comparing the it is case sensitive also. So when only hi is equals to hi, then only it will show true. So let's say, so see. So also other logic comparison operations, then logical operations also, and, or, not, those all things can be done. Like say you have kind of two conditions. Okay, so say for example temperature should be above this, and also the some other parameter, say some coefficient should be below this. So you can use AND operation. So say we can say 1 instead of 1, we can take it as 5 because it's already false. So you can see whether it's, now it should be coming true. So true. So this is how you can do logical operations also, and you can do multiple logical operations also, like or. So here you can say this and we should have 5 less than say 7. Okay, so true. And if I change this 5 to 4, then it will become false. Okay, so because OR is choosing between best of 2. Okay, whereas AND, then we have done AND, then that means kind of logical multiplication. Okay, logical multiplication, if both are true, then only it will be true, otherwise it won't be true. Okay, now coming to something called if and else statement. And if and else statement is nothing but a decision making thing. Say if this happens, then do this, else do this. So you can do simple comparison. Say if I am comparing two numbers, so instead of this, what I will do, I will have say two numbers, a equals to, let us assign 67, b equals to say 78, and let us have third variable also. We will see how to use the nested if also. Okay, c equals to, you say 54. Okay, now what we have to do, we have to print the largest of 3. Let's first take the two number a and b. If a is greater than b, then print a, like a is greater. Okay, now then what you can say, else print b is greater. Now since we are using if statement, I am giving print command. If I don't give print command, it won't display any output. Okay, so this is why print is important. So say b is greater. Okay, now if I want to compare c also, so what I have to write, we have to write if, and then again we will have a comparison that A is greater than C also, then A is greater than B. Okay, then A is greater than B. Okay, and inside this we have to see if A is also greater than C, then and then only print A is greater. Okay, now otherwise what you have to do, if you need to check for the second thing, which is say B is greater than C. Okay, since A is not greater than if A is greater than B, then it will check for A is greater than C, then A will become greater. Otherwise you have to check for is B is greater than C. If B is greater than C, what will happen? Print B is greater. So that means the first condition, A is greater than B, failed. If we check for B is greater than C, then B will be greater. Otherwise, if both condition fails, what you have to do, else print C is greater. Okay, so this is how you use if else statement. So we got the answer, B is greater, and you can see here this is true. So if I reduce the number of B, say 9, and if I take it as 10 and run again, then you will see C is greater. Oh, sorry. So what is happening here? Here I did a mistake. So if you see here, and if we have A is greater than B, if we see A 10, B 9. So this is how you do dry run also. By mistake I did this. So here what you do, A greater than B, you check for A is greater than C, it is false. So it ended the if here. But here what you can do, here you can put another statement here. So if this is true, you can say if A is greater than B, false, then check for B is greater than C. If that is also false, then you can see check for then C is greater. Let's see whether this works out or not. So C is greater. Now let's again go to something called B is greater. So it's not printing anything. So what is happening here? A is greater than B, it's false. Okay, but there should be a statement suggesting comparison between B and C also. So here we should have similar else if comparison between B and C, where to print B is greater, and then else C is greater. Okay, so let's run this. Now let's make C more greater. Let's see, C is greater. Now we don't have any loopholes in this if else statement. Okay, so this is all the basics. Now there is something called loops. Loops is like a sigma operation. Okay, and it's an iterative operation. You can go back in a loop means like you started something and you can print means you can go in a line in a circle, and while completing that circle you can finish certain jobs. Okay, it's, you can imagine like that. So if you have a sequence of numbers like 1 2 3 4 5 6, let us take one more number. Okay, now for statement you can for statement there is how you can use for statement is for some variable, means like you are assigning iterative variable. This is something called iterative variable. Okay, that in sequence means the set operation, you remember, means like sets. In sets what you say, if this item in this, then print this. Okay, now for is saying this item is in the sequence, this sequence means this. Okay, and then print item. So what it will do, it will start from the first part, 1 2 3 4 5 6, it will print like that. Okay, now the same thing, if you can print, instead of printing the item you can print anything. Now also there is another way to define loop, is using something called range. Okay, instead of just showing kind of say showing what are the inside list, what you can do, you can print use the kind of numbers or the range of the variable to show what is in the to show something, or so you can reiterate that loop for that amount of time. Say I will say in range of 0 to say 6. So print, instead of item I can print I. If you run it, you can see it will go up to, oh sorry, I misspelled range, so it will go to 5. So 0 to 6 means 6 times it will iterate from 0. So n minus 1, the last variable will be n minus 1. Okay, now the one thing we can try out is, say we have already a sequence. Okay, what I will do, I will iterate it to what, I colon. So we will see a kind of a beautiful pattern here. Okay, so this way you can play with it, and also you can just say colon I. Okay, and plus 1 I will give. So you will have this kind of pattern, because it will go to colon to n, that means n 0 to n minus 1 it will print. Okay, so this is how you use for loop. And there is something called while loop. While loop is iterative loop, which kind of loops around, or means runs whatever inside the loop till the condition is true. Okay, so means say you have you want to do a Newton-Raphson approximation, or some kind of approximation of a function. Okay, so you want to find a root of a function. Say you want to be correct up to 2 decimal places. Okay, so what you will do, you can put a condition here, or say x is equals to, say you know the near about answer up to 2 decimals, say 4.35. if it is there, then and then only it will exit the loop, or else it will be or it is more precise, then it will exit the loop. Means when this things is when the while loop is false, then and then only it will exit. Okay, so so if I have while equals to 1 and where I is less than 5, so it will go up to 4. 1 2 3 4 4 iteration. So similarly, what I said about range, when we define range, it will give a value, means it should iterate from 0 to 5. Then also you can see list range. Range defines the iterative numbers. Okay, so that way you can define range. Then what you can there is something next thing on the agenda is list comprehension. How you can mm, have you can understand list a bit more. Okay, so if you have a list, say here X. Okay, now I want to append into a list, means I have few values or few values which is being generated from some other thing or some other loop. I want to, I have some list of items. I want to append it into a new list. I want to create a new list. So what one can do, one can have an empty define an empty list, and using append command you can append the X list to this, and you can have the another list. Say here what is happening, whatever the items in X are getting iterated one by one, it is means doing a power operation. Say if I have 5 here and run, so it's order of 5. You can make a geometric progression, Fibonacci series, whatever you want using loop. Okay, so and this is what is called shorthand writing for list appending using for loop. So how it is done? The shorthand writing is like, say the end product will be a list wherein the you should write the operation or assignment. Okay, then the for, then the iterative variable, or you can have the element. Then you can look in, or in you can use in range also, of whatever value you want to iterate. Okay, so this is how you can have a shorthand notation for the assignment of variables using for loop. So now coming to something called function. So say if functions are very useful tool when you are doing kind of redundant operations, like say you want to calculate the noise power, for example noise power, given the value of noise temperature of the system and also the bandwidth. Say, so I will say there noise power PWR. So what I will give the temperature T, comma frequency FREQ, and then what I will do, I will print the power in dBm equals to, I will have this, then dot format, and inside this what I will do, T, and this is not frequency, it will be bandwidth BW. Okay, T times BW times 1.38 E minus 23, then not dBm, sorry, we will give in watts. So for dBm we will see what we can do. afterwards. Okay, so we will have redbox constant and everything. So bandwidth. Okay, so this will print this. So if we define this, now what I have to do, I have to just call this function by noise power. I will assign 400 Kelvin of temperature with 6 megahertz of bandwidth and press enter. So this is our power in watts. Okay, so this is how you can define a function and then call again and again and see what is happening. And then you can also have something called return type function. Return type function means you are returning the value to another variable. For example, I am returning return. There is a keyword called return. What you can return is the calculated power in watts. So instead of just printing, you can assign in power a variable to it, and if you see here, you will have power in watts. Then you can say PWR. So none. Oh, this is coming none because I didn't compile this. So don't forget, if you change the function, then again also you have to compile this. Now it will show the value. Okay, so if we do this also, this will show the value. So I am doing this on the fly, and you will find some mistakes in this, and that's how you learn. Means if you do mistakes, then see what is happening. Actually, there might be some error in your logic or in your assignment. Okay, now this is how you do. And there is also something called lambda expressions, where you directly just return the value multiplicated like this. Okay, where you assign for some trivial tasks. Okay, now lambda function, like var is equals to var into 2. So it will say it will define a function which will map this thing. Okay, now here if you see map and filter, actually in this what you can do, you can map, say times 2. Times 2 means you can map this function, say lambda. In a lambda expression, what you have to do, you have to say you define this function. This is something called multiply by 2 function, and you define a lambda function. Okay, where you can define lambda function is in single line statement. You can define anything. Okay, say okay, now you have a sequence. You can map this sequence to the function, and the following list will have everything multiplied by 2. Okay, when you map it, means you say that take this list and do element wise multiplication by 2. Okay, means you give, instead of having a for loop and giving, means running a for loop like we did earlier and providing each element to the function, what you can do is something called map. Map is means assign every element and do the operation of the function. Okay, and similarly you can map a lambda function also with that, and you can do different types of other operations, but these things actually is not needed. This is just an extra item which might be helpful for you, but okay. So the things which we need is till here. Here means what are the different kind of data types. So this is something called string operations, which you can go through. It's very simple, where you can means send everything to lowercase, uppercase, and you can split the names. Okay, then assign splitted into items and all, means you can have dictionary and all those things, whatever you can do with that. And there is something called pop and push in the list. Means pop means it will remove the top item from the list, and sorry, bottom item from the list. Top item. Okay, top item means 0 1 2. Okay, 2 is the topmost thing, so it will pop out the topmost and then you can insert there. Okay, using push command also. So now this is something which is important to us, which is called NumPy. NumPy is a library, Python library, which allows you to have array of variable. Array is nothing but a list of variables which can store a single data type. Okay, if it has numbers, it will store only numbers, no other list. Okay, no other data type. So you can have you can define a list by this, and you can convert it into an array using np.array mylist. Okay, or you can have list of list. So arrays are kind of symmetric. You cannot have not symmetric means it has a particular order. Say it is 3 cross 3. If I remove this, let's say if I run this, you have an array, means with, and if you something called shape command, so it will shape. Okay, so it's not taking the shape command, so there is another thing, np.shape. Okay, so it's saying np not defined. Okay, so because I have not run this, so library is not imported. So in MATLAB, Google Colab app, all libraries are almost there. So 3 cross 3. So 3 cross 3 matrix it is. Say if I do this now, it will throw an error. Okay, so it threw an error. What it did, it only took to the first value and stored it. So if I make it an array, try to make it an array, it became something array of list. Okay, so each element of the array is list. You cannot treat it as a array. So the beautiful thing about array is you can use that as a matrix. Okay, and matrix solves most of the problems in our linear algebra. So that is very powerful tool. So here what you can there are different operations. You can define an empty array as zeros array, means it will be filled with zeros. So if you have 3 linear 5 cross 5, then you can also have 3-dimensional arrays also. So, and there is something the basic command, something called linspace, where you can define variables linearly spaced variables. Okay, say linspace 0, 10 start end, and you should have number of how much number of elements should be there. So start and number of elements, so 1 2 3. Okay, 0 1 2, that means total of 3. Now 50, so it will define 50 number of variables. Then there is something called I, which creates identity matrix, which is useful again for matrix operations. Now if you want to generate random variables, what you can use, there is some library called random, np.random and rand. and 2 means it will give you 2 random variables, and 5 cross 5 that will give, so it will give random variables between 0 to 1. Okay, now if you want to have between 0 to 100, you can go ahead and multiply it by 100, no problem. Okay, you will get between 0 to 100. Now there is something called rand n also, where it has both positive and negative values. So -1 to 1 is the range of that. So okay, and something called rand int, which will only give integer random variables else. And then there is something called reshape. Okay, now reshape is, say if you have a long, say 25 column matrix, say 25 column matrix means only one row and 25 columns, say. Okay, so I will say ARR equals to np.random.rand n, say 25. So ARR will become, see, the ARR will be single. Okay, now dot reshape, I will have 5 comma 5. Okay, see, it will reshape it into this. Now let's again I will just do this and separate this code out. This code out I will separate it and paste it here, and here I will only print try to see array ARR. Okay, now here see how it broke down the array. So it took first 5 elements as the first row, next 5 as the second row, then after that next 5 as the third row, like that. So you need to always be careful how you distribute it. Okay, so that is a way you have to do it. So now what we can see, say it is not 25, say I have 36, which can be so 6 comma 6. Okay, now remember to run this one first. Okay, so here if I do 6 comma 6, it will create it 6 comma 6. Now but 36 can be represented in another way, so I can say that as 4 comma 9 is also 36, correct? See, 4 comma 9. Now let's say we do it 6 comma 6, and again now let's see, let's print ARR, but it's showing one dimensional array. You reshaped it, but you didn't save it into the array. So what you have to do, ARR equals to this. So now it will reshape and store in ARR, and then if you print ARR, you will get this. And if you again try to reshape this into 4 comma 9, it will reshape it again by same thing, means the first 9 elements will become the first, like that. It will, first of all it will stack and linearize it, then it will reshape. Okay, you need to be always be careful how you are reshaping it. Okay, now there is something called min and max argument, which is used to find maximum and minimum numbers in an array. Okay, then there is something called shape, which was actually failing earlier. I don't know why, but you can yeah, that is because I didn't use this. So now let's see if I see 6 cross 6. So shape, because I didn't ran the NP library, so it was not showing shape. So NP library. Now now there is something called D type also. Yes, you can see what is the data type inside the array. So this will be float. Okay, D type. Here array has been reassigned and all, but what we are using, float 64. Okay, so generally the data type is float 64. If you want to specify into another data type, it can be done. So now there is something called indexing. Indexing is in a similar manner as we see in list. So that's there. Then using brackets notations you can do there. Then also broadcasting. There is something called broadcasting. Say if you want to have from 0 to n values same as the something, so you can assign it like that: 0 start value, and it will 5 is the end location, start location, end location in the array. And that will be changed to 5, changed to 100 as shown here. So if you do this, see, it changed to 100. So why this? Because this is taking number of rows. Okay, I have not specified columns. So every row 0 to 5. 5 is not 5, n minus 1. After colon, it will go till n minus 1. Whatever n written here, n minus 1. That is to be taken care of. Always you should keep in mind. Then this is also called slice of an array, where you have means 0 to n minus 1 number displayed. Okay. Now you can also assign everything the same. Also there is negative indexing, something called negative indexing. Okay, say I have I will rearrange the array. So I say if I want to show the last value, not the front one, so I will slice it. I will tell show -1. Okay, so here what you can see, 10. So how the indexing is assigned in an array or also in a list is, the first element is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 elements. So 11 elements, so 0 to 10. Okay, but it has a inverse indexing also, where it can be written as -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, and -11. So minus indexing, that is also kind of slicing. Say if you want to go, say I will write -11 colon -1. So why this n minus 1? Okay, so you have -1, -1, that is -2. So if I say here 0, let's see what happens. Nothing, because 0 is 0. Okay, if I put it a colon, it will show all the things. Okay, because it's considering minus thing to the end. Okay, so end is towards the 0. Okay, in negative indexing. So coming to the 2-dimension array, you have 2D array, and in that just like list, you can use to display the element like this, say, okay, if I press 1, it will show row. So row format is row and column. So here I can see second rows. I want to see third element, which is 2. So we will get here some value. So also instead of this, you can use comma notation where this one is row and this one is column. Okay, and also you can do slicing in array also in row and column location. Okay, so this is what is called matrix. Means you have n number of rows and number of columns. Matrix and defining matrix in for loop. Okay, okay. Now this is the kind of summary of something called indexing, or how the data structure will be look like. Okay, so if you have a matrix or defined an array like this, so data type is what is called the whatever the value it's storing data type. It can be 8-byte integer or something else. A shape will be the shape of this, how much by how much. So for row by column, 4 rows 3 columns. Then strides are 24,8, that is means number of how much bytes it's consuming or something like that. So one segment is 8 bytes per element if it's an integer. That's a different thing. When you go into approach it into a computer science manner, then it is okay. So now there is something called vectorization, which is our part of interest. So what you can do, you can add array to get the resultant. Means you can do kind of simple multiplication to get the variable. Now there is something called broadcasting. You have a single array and you multiply it by this and you will get 2D array. Okay, so you can do reduction also. Okay, now there is various things you can do. Also there are several functions inside this NumPy library. Something called we can use mean operations. Okay, now let's move on to NumPy operations. So you can arrange, you can divide it by just dividing means you are doing element wise division. Okay, element wise division means the first location will be divided by the first location of the other matrix, like that. Okay, now the double star is power, as we discussed. Now coming to universal array functions. Okay, you can find out a square root of each element inside an array. Okay, then you can find the exponential to the each element is what. Okay, means say you have an array of, let's define an array here. This is an, let's do this. So array, you will define an array, and if we do to the power, we will get this. Say if we do the exponential, what we will have is e to the power 0, which is 1, e to the power 1, which is 2.71, like this. Okay, now if you want to find the maximum value, we have to do np.max sign. If you want to see the sign values of each element, we have to do the sign log. This if you want to do the log. Now there is something we defined a function power calculation. If you want to do something, let's define it again. So if you want to calculate power in dBm, so PWR dBm, say we took 400 as a 400 Kelvin as a temperature. If I remember correctly, 6 E plus 6 megahertz of bandwidth, and 1.38 E minus 23 our constant. Okay, now I want to find out in dBm. That means what I have to do, 10 into, I have to use log 10, np.log of 10. Okay, now this done, and then minus, plus, this will be in dBW, watts, plus 30. We will have power in dBm. Now to display PWR and dBm in notebook, not in other thing. So 104. Okay. So then coming to another type of data type, or means this is a different library called pandas, which is used to define something called data frames. Data frames is advanced version of matrix, or it's not matrix, but it's a kind of table, okay, where you can have different data types also for a matrix. Okay, say this requires a bit more of understanding, and if you are more towards handling different want to handle different kind of data types, this you should learn. Okay, but just for general representation, what we can do, we can just go through it. Okay, so here what we will have, labels, my list, and we have some kind of array. We will create a dictionary, and using series we can create panda series. Okay, and then also we can assign different labels to it, different instead of 0, 1, 2, 3 index, we can define one ABC index, and also this can be taken as this, the means like different kind of notation to write it. And if you say only provide the arrays to PD series, it will just create the normal panda series. So there are many other operations what you can do. It is very useful when you want to assign some kind of category and create a sorted data set with a key and all, and means when you want to have different kind of, say you want to have a grade sheet of multiple students. So what you can have a key as a roll number, which will call as index. Okay, index will be unique for everyone, the roll number will be unique for everyone. Then you can have name, their marks, their total marks, average marks, everything you can do. So this is very helpful for handling different kind of data. Now there is something called data frame. The data earlier this was all example of panda series. Panda series means data series. So series will have only one column, whereas data frame can have multiple columns. So like this. So you can assign index and columns like differently. So and you can see each selection, means if you want to see means a data frame as a means one column only, what are the values in one column, you can just print that, and multiple columns you can print that at. Okay, so there is another way to denote, which is dot the column value. That way you can also denote. Then you can also see the data type, what data type it is. So if you want to see the what is inside it and its data type, so you can index it like normal array also. This is W of 0. Okay, so df is not defined, it's saying because I have not ran this thing. Okay, so the first thing to solve an error is read the error. Okay, so so what you can do, you can read here rand n is not defined, so I have to run this one. So rand n can be defined, and then I have to do this, read the error carefully, then you will be able to do, you will be able to resolve it quickly. So now if I run this, so float 64, so the data type of the 0th location is float 64. Now you can do addition of 2 columns and all those things. You can create a new column by like this, and so on. So simple, means if you go through this notebook, you can find all the basic operations, how to do that, how to select rows, means how you select rows. So for selecting rows, you need to use an inbuilt function called loc, and you can specify row A, B, C, D if you have changed the row name. Otherwise, it will be 0, 1, 2, 3. Okay. Now collection of series. So you can always do different kind of operation, logical operations. Say if you want to find whatever the value greater than 0 is, so you can just display that and find out what are the different values which is greater than 0 in W. So it's saying in W, whatever greater than 0, show that all the values, also all the values where W is greater than 0. Okay, so it's showing like that. These are all means kind of selection gimmicks. If you are more into selecting a few particular type of thing, this is just kind of extra bit. Okay, so this is then there are multiple types of things you can learn by simply going through it. And also there is one thing which I would like to go through before concluding this is, so missing data, is yeah, this one. So here what is shown is how you can load data into a data frame. So you can read from file also. Okay, so I won't run this because it needs to connect to drive. Okay, now you will be given some example files and all where you can run this and see. So you can read it using, means if you have a CSV file, you can read that. And also you can save as a CSV file. Then you can also read from Excel. Okay, using read Excel command. Also you can read from you have to install few libraries if you are using Anaconda, which is also Anaconda software, which is used for Jupyter Notebook too. So you can read it from HTML file also, where you can say read anything from, read a table from the particular website link. Okay, so gone through many things, and you can also say that only read a table which matches this thing, something some literal. Okay, there. So that also you can do. Okay, so with this the first part I would like to conclude for the Python course. Okay, so so we will start next with data visualization. Okay, so let's come to the next part where we will talk about data visualization. So what we'll do here, that we will try to visualize the array or the values in a graphical manner, okay, or in a pictorial representation. This is important in order to what we will be doing in the next session, and that how to see what are the how to graphically observe Fourier transform, what it means by different kind of aperture distributions. You already saw in the lecture that how it looks graphically. However, we will see firsthand how it looks. Okay, using programming, and you can do it by yourself. Also, if you remember correctly, we on one of the tutorial we said that we will do electromagnetic simulations or kind of visualization using Python also. That also we will try to do. Okay, so basically anyone, if I say in the simplistic words or boil it down to a basic level, what simulation is nothing but representation of your system or a dynamic system using codes. Okay, so using certain algorithms or certain set of formulas, you say how the system is mutating over time or over space or whatever. Okay, this is what simulation is. If in fact if you try to plot y is equals to mx plus c, in a sense it is you can say that it is a simulation you are doing for a straight line. Okay, where you mutate the x coordinate to observe what is happening in the y coordinate. Okay, so so this is very I think in a means like a rudimentary way or rudimentary way we can say we are simulating something. Okay, simulating means providing a stimulus and observing what is happening. Okay, so there is particularly different libraries using which you can visualize. There is something called matplotlib, cbond, built-in pandas function is there, plotly, coupling, and geographical plotting is also there. So we will discuss about matplotlib, and this file is shared and you can go through cbond and everything. Step by step things are given and you will find it very easy to do, easy to perform different kind of plottings. Okay, so just you have to first install matplotlib if you are using Conda environment, or if it is there then you need to install it. So you have to first import pandas library as PLT. PLT is a kind of a like a something called object for the library by which you can access the library functions. Okay, which I didn't tell it earlier, that import numpy as then np, all those things are written, but this is something called object, which is a kind of a go between the actual functions inside those library. Okay, so you can give it any name. Instead of PLT you can write P, A, B, C, D, but PLT is kind of unsaid rule to write matplotlib.pyplot as. Okay, now this statement says that this statement is for or Jupyter notebooks, where it will show the inline result directly without saying plt.show. Means if you want to use matplotlib, you have to define what the plot function will be, and then you have to use plt.show to show that plot function what is generated. Okay, so if you use this, then it will directly show the plot instead of putting plt.show. Okay, so we will also define import numpy. Okay, and this is something called means we will provide a linspace variable. If you see x is like this, and y is defined as x to the power 2. Double star means to the power. Okay, so if you plot this, it will be plotting like that. Okay, so plt.plot PLT has a function called plot, okay, where you have to define x, y, and R is the stands for color, red. So you can change it to say B, it will come blue. Okay, now if it is say K, it is black. K is for black. Okay, then again R is like this. Now why this is happening? Because in somewhere during the end of the program, someone we have written here plt.show. If we remove this, then also it should plot. Okay, see, it should. Okay, now if you see this, see, now you can use subplot. Okay, there is something called subplot. If you have a figure window, it will means assign row and column to the each section of the plot. Like 1, 2, 1 means the subplot will have 1 row, 2 column, and you should you have to place the first plot in first location. So it will define it like 1, then 2, 3, 4, 5, 6 if you have multiple rows. So first one you have to do this, second one then y comma x. So this thing, and gr minus minus means showed in dotted line, star minus means this. So you can use different means combinations. Say if I use O minus, so like this it will come. Okay, O minus and all those things. So this shows that how to set x label, y label. There is command set x axis, y label. So this is different kind of representation, different kinds of representation to plot. Okay, but the same means this can be used here also. So directly you can plot like this. So this till here it's important to understand till here, this portion, because we will be using till this portion only to plot. Also this other kind of another kind of representation to plot. Okay, so now moving on, you can have plot in plot by means defining the axis and the means like the box. Say main box is 0.1, 0.1 this, and the inner box you can define something else, and then if you see it will have box in box. So you will see this this is the large enlargement is happening just because somewhere in the end of the codes I have increased the means value of the increase the font size to a certain extent, because of which this is happening. Okay, so just to I will restart it and start it again. Okay, now if I start it again, so this won't happen. Okay, so somewhere in the down the code you will see that I have changed the font size, due to which this kind of shitty thing is happening. Okay, so you can create an empty figures also like this, and on that you can plot. okay, like this. So using calling that you can plot. Okay, now if I go further, you can go through it. Means it's all just specific means kind of notation, specific kind of notations here. uh, so you can just follow through, and it's just easy, means the thing it's easy to understand. And like say here, you can create means you said uh, we already created two empty plots. Okay, you empty plots by this. Okay, and using for iteration we try to access each of the subplots. Okay, and plot in that. This is how you do in a iterative manner. Okay, so now there is something called, you can set the figure size, aspect ratios of these things, say like this. So figure size 12,3, that means you will have uh, means um, let me just run this. Okay, so this will only create a means figure size. So now here if we have a subplot, it will have like this. So figure size, it says 12,3. So that means you have 12 pixel figure size of 1200 cross 400. So 400 is in the width and 1200 is like this. Okay, length and width. Okay, so here you can save the fig file using save fig command. So in fig, and this you have already created, and then fig.save you can use to save. However, you can, if you are not using this kind of notation and you are using using PLT, then you can say PLT dot save fig. Okay, so that way also you can save the figure file. Now setting the title like that, setting the title is like access dot set title, this and that. Now here also you can add separate titles, like coming to the label part, right, this one. So if you want to plot multiple things in a single plot, you don't have to again assign xy kind of variable. If you want to plot in a multiple way, the general command is plt dot plot x1 comma y1 comma x2 comma y2. This is the general command. Instead of that, what you can have the separate plots, and one after the other it will plot one over the other. Okay, so instead of PLT you can just define the axis and or figure separately, and on that you can plot. Okay, now there is different locations which you can give to the legend. Here legend is this label. You can there is a keyword called label, using which you can define anything. Here like here I can say a square. Now here I can say cube. So if I run this, so here it is square and cube. Okay, square and cube. Now this is a kind of a keyword which defines the label, and it will if you invoke legend keyword, it will show. Now you can change the location of the location where the legend occurs. So this is the standard places where you can say. So lock 0, if I say lock 4, it came here, lower right corner. Okay, now let's see the different types of formatting to the lines, means where you can change the color and show it better to the viewers to so that they will be able to differentiate. Say for example, you want to write a research article where you have to do multiple plots, but some might take a black and white printout or have a black and white version of it where they won't be able to differentiate with colors. So it's important to show them with different means line formats. So dashed line, dot dash line, there's different kind of, say you can use dot dash, again dot you can use, and then you can plot it. See, dot dash dot, that can be used. Now also you can give a hex value for the color code if necessary, if you don't have enough number of colors available. Full value, full name of the color you can give, and you can assign markers, then line width, different line width, and line style also. Line style, ls means line style. Okay, line width and line styles like this shown here, and which will result to these things. Okay, now if you have multiple subplots and you want to have custom text access and also the titles, here you can use this setting title as set title and invoking the which number of axes you are trying to set the title for, and also you can change the limit of the x-axis and y-axis using xlim and ylim command. So if you are using this kind of notation where you have fig and axis and assign a subplot to it, okay, so here axis represents the this axis where you are plotting, and whereas fig represent the entirety of the figure which you can save it later. Okay, now in this case you need to point out the axis on which you want to plot. But if you are using direct command like plt, you can for plt, if you are using plt, there is command called plt dot xlim. You don't need to have set xlim or ylim. Okay, you can directly use plt dot xlim. So, okay, xlim or xlabel if you want to label it. Okay, so there is another type of plot which is called scatter plot. Scatter plot, they will only plot in points where it is, it won't join the line. And then histogram plot is there. Okay, and there is also box plot where you can see a bunch of data and the error bar also and the mean also. Okay, which is very useful for statistical studies. Okay, and there is other thing called range scaling and different beautification add on to the plot here on. So this is how you plot it. So this is the basics you required for what we'll do in the next session. And of course you can this is very detailed notebook which you can go through by yourself and see what are the different things, and of course you can get back to us on discussion forum as well as you can write back to me by if you have any query. Okay, so with this thank you, and this is my email ID. You can always write to me and your queries are always welcome.